So you're going through the Maths Advanced paper. Looks pretty easy so far. But wait, how do you do this? Or this? Or any of these questions? Don't worry, because Ace Academy has got your back. How's it going, everyone? My name is Yasser and I'm the head tutor of Ace Academy. Today I'll be going through the MCQ questions for the Maths Advanced HSC paper 2024. So, before I get started, I really recommend you guys to get a pen and paper and try these questions with me. And yeah, check your solutions with me and let's get started. First question is asking for the equation of the function. Let's have a look. So, the equation of the function is going downwards. So I can immediately cross out A and B. Why is that? Because the coefficient of x cannot be positive because it's going downwards. And now I can say that the y-intercept is in the positive area. So it has to be C. Alright, let's go to the next question. Question 2. In a group of 60 students, 38 play basketball, 35 play hockey, and 5 do not play either basketball or hockey. So when I see these type of questions, all I want to do is draw my Venn diagrams. Okay, so 5 don't play any, which leaves this part to be 55. And they said 38 play basketball, so let's say this is basketball, this is hockey. 38 play basketball. They didn't say basketball only, so this whole circle is 38 and this whole circle is 35. Okay, so now you're wondering, how do I get the students that play both? So this is the question mark. Alright, so what you want to do is you want to add up 38 plus 35. That has to be 73. And that's both basketball and hockey. And what you want to do is you want to minus 73, you want to minus 55 from 73. And that's going to be 18. So this will be 18. And there we go. We have question 2 done already. Let's move to question 3. Alright, moving on to question 3. We have to figure out which subject Pierre did the best in. And to do this, the trick is, let me give you an analogy real quick. It says normally distributed. And if you want to figure out which subject Pierre did the best in, it has to be a really high Z-score. The Z-score has to be really, really high. Okay? So, what does this mean? It means Pierre's mark is way higher than the mean. Okay? So let's have a look at Pierre's mark and the mean. So this would be 6678. So that would be 12. And the standard deviation is 6. So if you divide 12 by 6, you get 2 standard deviations here. So 2 sigma. Over here, it's about, let's say, 0.9 sigma. And then over here it's 7, so it's like 0.5 sigma. Over here there's a big gap, but is the sigma large enough? That's what we have to figure out. So 85 minus 72, that's 13. 13 over 9, I'll say that's like 1.4 ish. Yeah, so the biggest sigma we get is in English, so it has to be A. Once again, I want to emphasize that even though in history she got way higher than the mean, the main point of this is the Z-score. If the Z-score is really high, that's how you know you did way better. Alright, let's move on to question 4. Question 4 says the parabola, and they gave the parabola's equation. It's reflected on the y-axis and then on the x-axis. So we can kind of sketch this. So x minus 3 should be somewhere here, then x minus 3 minus 2, so let's say something like this. And then it's reflected about the y-axis, so we can do this. And then the x-axis, we can do that. Should come down a bit more. Alright, so our equation should describe something like this. What's the trick to this question? Alright, so when you're reflecting an equation, a parabola, about the y-axis, what you want to do is just replace the x with minus x. Alright, so let's do minus x minus 3 whole squared minus 2. Cool trick is you can take out the negative, so x plus 3. Remember, this is still in the brackets, so that. And you can take out the negative as well, because negative squared is just 1. Right, so you do x plus 3 whole squared minus 2. So this is the first transformation. That's the y-axis one. So going from here to here is just flipping it on the y-axis. Alright. So now it says it's reflected about the x-axis as well. What you want to do is, when you're going from this equation and reflecting it, you just add a negative. So x plus 3 whole squared minus 2. Just distribute the negative sign, so negative here, and negative becomes positive, so it has to be C. And does this describe our parabola here? Yes, it does. The one, it's upside down and it's shifted by 2, shifted to the left by 3. So yeah, that's a double check. That's why I like to do my diagrams. A quick tip I can give you guys is, whenever there's a equation that describes a curve, always do your diagrams. Because with this, I did this mathematically over here, and then I did the graph over here, so it's a double check, you know. But when you're doing the multiple choice questions, I always recommend doing it this way, because it's just faster, and MCQs you're supposed to take like 1 minute each. Alright, let's go to question 5. Question 5, take the integral. What you want to do is, I call this the wishing formula, yeah? So we have the integral 6x plus 1 whole cubed dx. So now what you want to do is find the derivative of this. Derivative is going to be 6. We want to wish for a 6 here, okay? So what you do is you wish for a 6 in the inside, but since you spawned the 6 out of nowhere, you have to divide it out by 6, so it balances out, the equality balances out. And now you just integrate. What you do is step it up by 1 power. The derivative gets absorbed. That's how I like to imagine it. Divide by the new power, and then the 1/6 comes here. So it's going to be 1 over 24. 6x plus 1 whole, yep, and plus C. So it's going to be A. Awesome. Alright, so let's move on to question 6. The domain of the function. The domain of the function is all the x values that the function can take. What you want to do is, instead of thinking about all the x values it can take, you're going to think about all the x values it cannot take. Alright? So at the denominator it cannot be 0. So you can write square root of x squared minus 1 cannot be 0. And inside the square root, x squared minus 1 cannot be negative, or x squared minus 1 has to be greater than or equal to 0, which means if you want to capture all of this in one statement, the square root of x squared minus 1 is greater than 0, because this condition is in here, but it cannot include 0, so you just take away the inclusion sign. Yeah. So what you want to do is solve for this. X squared minus 1 greater than 0, x squared is greater than 1. So you just do a quick sketch of x squared. Whoops. X squared is greater than 1. So where is it greater than 1? So 1 is here. Where is it greater? This side and this side, yeah? It's going to look like this, so 1 and negative 1. So this region is x greater than 1, yeah? And this region on the left is x less than negative 1, alright? So this is our condition, and if you want to write that in this notation, what you have to do is, so does not include 1, it goes all the way up to infinity, union does not include negative 1 and goes down to negative infinity, and that's 6 is D. Alright, let's move on to question 7. Alright, question 7. This is one of the trickiest ones my students have found so far. Alright, I have a cool trick to this actually. So what you guys want to do is, we're going from f of x to, let me just write it this way. So you're going from f of x to f of 2x minus 1. What is this actually? It's a transformation, yeah? You're taking this function and then you're applying this transformation. So you're replacing x with 2x minus 1, alright? So what you want to do for these type of questions is, first, you rewrite it, take out the 2, it's going to be x minus a half. Alright, and then you think of these transformations as just transforming the graph itself, alright? So what you want to do is, the 2 is attached to the x, so what I want to do is squish it. So when you squish it, 2 comes down to 1, and then 4 comes down to 2, okay? So this is me squishing the graph. Wait, so like that. And then you're gonna shift it to the right by a half, yeah? So you're gonna shift it to the right. I'm gonna try to draw that for you guys right now. And there we go. That's your graph. And which one is that? That would be C. Awesome. It's as easy as that. So let's move on to question 8. Question 8 is a bit more theoretical. Alright? So you gotta be kind of strong on how you visualize things, okay? So a box plot is shown below. What is a box plot actually? So let's see. A box plot is saying that this is Q2. Wait, let me just zoom in for you guys. There we go. Okay, so Q1, Q2, Q3. Alright. It says that this is 25%, 25%, 25%, and 25%. So it's saying that 25% of the data lies here, 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 and here. Okay. And from the shape of the box plot, you can tell it's pretty uniform. Okay, so what you're going to write down is uniform. Now, that's the key feature about this box plot. So now the question says, which of these histograms is not possible? Okay, which of these histograms is not uniform? That's what we're looking for. Okay, so at first you might say, B doesn't look uniform. But let's have a look at B. Okay, so most of the data is concentrated here. Okay, now if you think about densities, okay, how it's packed, how the data is packed, this is how you have to visualize how the data is packed here. Even though it's packed here in the midpoint, right here, right? There's more here. So wait, let me just have some fake numbers. 1, 2, 3, 4. Actually, let me have 0 as our middle point, and then 1, 2, 3, -1, -2, -3. Okay. What this histogram shows is how many numbers are there. Okay, so there's 3 -3s, so -3. You can pick any number. I chose 0, 1, 2, 3, and then -1, -2, -3, because it's easier for me to visualize that this is the middle point. Okay, I call this the middle density, how I like to visualize it. Yeah, so the box plot, what it shows is 25% of the data lies here, 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 and here. It's uniform. Okay, which means that the density, when I talk about density, what I mean is if you had to take this 0 right here, and if you had to times it by how many zeros there are, okay, 4 times 0 is 0. Okay, so it's gonna distribute evenly across here. Alright, if I were to show you another example over here, this is pretty uniform. Okay, let's say this is 0, 1, -2, -3, -2, and 3. This is gonna distribute evenly over here. Okay, and over here as well, this part and this part, think of it as like it could like fall down and distribute evenly here. Okay, it's not really how it works, but it's really helpful to visualize D especially. Okay, the reason why the answer to this question is D, because if you have to look at this histogram, there's a big point here, there's a big bar here, and there's a big bar here as well. Okay, the center is really dense. Okay, and then it falls off over here and it falls off over here. Okay, it falls off here and here as well, but since the center is dense and it increases this way and this way, do you see the magnitudes that I'm talking about? The magnitude of 3 is pretty high, the magnitude of -3 is pretty high, but 2 is kind of medium, 1 is kind of alright, 1 is just 1, right? That's why it fills up. But the higher the number, the less there is, okay, in this graph, in this histogram, I mean. The higher the number, the higher the magnitude, the less there is. So it's really dense around the center, so that's why it's not going to be uniform. You can try writing them down like this and then do your calculations for Q1, Q2 and Q3, but since this is a multiple choice question, I really want you guys to visualize this, okay? Visualize that due to this and this being really centrally focused, the densities are not going to be uniform, alright? So that's why it has to be D. If you have further questions, please comment them down below and I'll try to help you guys out, alright? Let's move on to question 9. So question 9. The first time I took a look at this question, it kind of stumped me for a second. A bag contains 2 red balls, 3 white balls. He chooses at random and then at the same time as well. And these are the outcomes, alright? So the question is, given that one of the marbles that Jovan has selected is red, so given that one of the marbles is red, 1R, okay, given that one marble is red, what is the probability that the other marble that he has selected is also red, okay? So first thoughts, most students, and including me, first thought that, okay, given it's red, the other one has to be red, so it has to be 1/4. C, boom, easy. No, and it gets kind of trickier than that, is because if you write it out like this and do the probability calculations, so let's do RR, add these up, 1, 2, 3, okay, so the probability of at least 1R, it's going to be 7 on 10, okay, and the probability that both of them are going to be red is going to be 1 out of 10. So what you want to do now is do 1/10 over 7/10, okay, 1/7. Okay, but you might be asking, why did I just divide this and this, and why isn't the formula 1R? Okay, why did I go from this to this? Okay, so the reason why I didn't use this statement over here is because if you had to think about the intersection between them, alright? So let's say the set of, so for the set RR, there's just this, okay? This is the only combination for RR, like both marbles has to be red. But if I said that for the set at least 1R, okay, they can be RW, WR, or RR, okay, and the intersection is just these two, so it has to be just the probability of RR, which is 1/10 right here, okay. So all I did was, let me just write this in red, okay, this I replaced it with this, okay, because like I explained here, if you look at the two sets and you're seeing the intersection here, the intersection between them, it's just going to be the probability of RR, right? So that's why I went from here to here, and 1/10 over 7/10 is 1/7, which is why it's B. Alright, awesome. Let's move on to question 10. Okay, so you're probably wondering, how the heck am I going to do this? Alright, what if I told you you can do this in just 30 seconds flat? Okay, before I tell you how to do it, I'll tell you something similar, okay? So in this question it says, this is the graph of y equals f of x. The point Q is a horizontal point of inflection, alright? Let a of x, so a of x, that function, is just the integral of f of x, alright? So how many points of inflection does the graph y equals a of x have? So Again, a of x is just the integral of this function over here. How many points of inflection does it have? Alright, so you might be wondering, okay, so when I integrate this, how would I imagine the function? So would it look like that? Would it look like this? Alright, screw all of that. Okay, all you have to think about is, let me just take you to here. If you integrate x squared here, what would it give you? It would give you x cubed on 3. Okay, but if you have to integrate it visually, okay, what's x cubed? X cubed looks like this, and x squared looks like this. So if you have to integrate this, okay, this function, it goes to here. This is what it gives you. So you're saying a stationary point, if you want to integrate it, it would give you a point of inflection. Okay, that's the trick to this, right? You just have to find how many stationary points are there in f of x. So let's see, there's 1, there's 2, there's 3. So you can say that there's 3 points of inflection in a of x, because, so if you had to follow this on the side, integrating a stationary point would always give you a point of inflection. It's that simple. Alright, awesome. So I hope you guys find this very helpful. If you guys have any more questions, comment them down below. I hope you guys are. And let us know if you guys want us to go through any specific papers. And if you guys really like this, just like and subscribe. You know the deal. And all the best for your exam prep.